Greetings, programmers. Busted Thumbs here, and we're up to our 5th installment now on our memory game. So welcome back, and welcome back to Fluffy Wishes, who's here with me.
Hello!
And at the end of our last tutorial on episode 4 there, we put together a little thing that shuffled a list that showed all of the board tiles that we were going to display. And Fluffy Wishes told me that I did a terrible job explaining it. So we're going to let her come in and do a better job, and she's going to explain exactly this guy that we called Random Shuffle of Board Tiles. She's going to show us what it's actually doing. And in order to do that, we put together a little bit of a drawing, and I'm going to switch over to that. At the bottom here is the code that we did to define that random shuffle of board tiles, and here's a little indication of what the list that we're working with and the variables. Variables are in these single boxes, and the list is right here. Now, Fluffy's going to take us through and describe what is exactly happening to make sure that our board tiles get shuffled randomly. Go ahead.
Alright, so in the beginning of the script, we set our stage index to 1.
Right?
Basically, the stage index is saying which item on the list we are going to be moving.
Okay, so we've got stage index. It's set to 1. That means it's pointing to the one item, the first item in this list, which is Snowflake. Got it.
Then we repeat for the amount of the length of the list.
Sure.
We set stage new index to a random number between 1 and the length of the list.
All right, so that's going in this case it's going to be 7. In the case we had before, it was 12 items. So let's pretend that that random number generator came up with the number 4. That would mean that we would be pointing at the 4th item, which in this case is the sun. Okay, then what?
Then we would set the stage temporary to item stage index of board tiles. That basically means that we're going to set stage temporary to sun.
To sun, right? So it looks up in here what the 4th item, the stage new index of the 4th item is, and it turns out to be sun. So we'll put that in here. That's what it just did. It set stage temporary to sun. Then
we replace the stage new index sun with item stage index. That basically means we replace the sun with the snowflake.
Right, so it says the item it's sun needs to be replaced. So let's get rid of that one. And it needs to instead have the item that's at the stage index, which is snowflake. So let's put that inside here. So this just became snowflake. Then what?
Then you replace the first item, snowflake, with the stage temporary, which is sun.
Right, so its stage index is pointing to snowflake, so we've got to cross that guy out, get rid of him. And we're going to look up the item that's in stage temporary and put that in here instead. So that's what we've got after, well, there's one more step. What happens is the last step?
We change the stage index by 1.
So
that basically means next time we're going to be using the frog instead of the snowflake.
All right. So there we go. We've gotten to the bottom of our loop. Let's go through one more on our loop and see what happens next.
We start by setting the stage new index to a random number, say 6.
Okay, let's say the random number generator came up with 6 this time. That would mean that this guy now points to tree.
Then we would set stage temporary to tree.
Right. Tree.
Then we would replace the tree with the frog.
That's right. So this guy ends up getting replaced with the guy that's here, frog.
And then we replace frog with stage temporary, which is tree.
Sure. So you can see then we get rid of that guy, we grab the guy from stage temporary, and we stick him in there, he becomes tree. And then stage index
changes to 3.
As our last step, it goes to 3. So you can see that what it's going to do is it's going to walk down for every item inside of here, and it's going to find a new place for it, and it's just simply going to swap the two. And so that little bit of code, it looks like a lot inside that particular script, but it's actually doing something pretty reasonable once you start thinking through what exactly it's doing. And it would just do that until it went through the entire list, and the entire list would end up looking randomized, which is exactly what we want. Now, to get back to our game, we need to now take those tiles and we need to make them show up inside of our application. And what you see in our application, in our memory game, is that we've got this big white empty space, and we need to fill that with the right number of tiles. But since there's so many different tiles, combinations that we can in terms of sizes, small, medium, and large, we're going to have to do a little bit of math to get that to happen as well. So let me see if I can go back to that PowerPoint where Fluffy was explaining the way that algorithm worked. That's what we would call this. The shuffling is an algorithm for shuffling. And I want to explain a few concepts which I need to do some math with in order to lay out our cards. So let's look at this other slide. When we're all done, we're going to end up with a grid that looks something like this. This is our small size. It's the 3x4. In order to figure out where the items inside there need to be, right, we're going to have to know exactly where we need to place them. And we've got some stuff at the top that's showing things like the score, and we don't want it to go all the way to the edges on the left and the right. So what we need is to have what we call margins. And so there is a top margin, and that top margin is going to be the Y value that we want the top of our cards to start showing up at. So I'm going to need to put a number in that says we're going to start putting cards in at this particular Y value. And because we don't want the cards to go all the way to the bottom either, we need to come up with a bottom margin as well. And that's going to be different than the top margin. So we need to figure out what that is, and we'll put that into a variable. And then the sides don't need to go all the way either, but I only need one variable for that because I'm going to make the sides have the same margin. So I don't have to say X margin or left margin, right margin. I can just say the sides margin. Then the other important thing that's going to go on inside there is we have to define what the padding is. And what is the padding?
The padding is the space in between the tiles?
Yeah, that's right. So what I'm going to specify before we lay everything out is what the smallest amount that padding could be. Because what we want to do is our tiles, we want them to stay square. And that means that we might have a different padding for up and down than we do from left to right when we're all done with laying everything out. But we want to make sure that we keep at least a minimum amount between all of those. So we're going to end up having to figure out what that up and down padding is. We're going to have to figure out what the size of the tiles are, and we're going to have to figure out where we're going to place each one of them. Okay? Are you ready to do some math to figure this stuff out?
All right.
All right, let's give this a shot. I'm going to go back to our Scratch, and we're going to start doing some of that, putting the variables in and figuring out what the layout is. So I need to start making some of these variables we just talked about. We need to have the top margin, and we need to have the bottom margin. Okay. We're going to need to have the side margin, and we're going to need to have the minimum padding. Okay, now when we're all done, we're also going to need to know the tile size. We're going to have to do some math for that. And then we're also going to need to know what the X padding is. Let's call it the padding X. And we're going to need to know what the padding Y is. Now we're starting to have a lot of variables here, aren't we? But that's okay. We need these. None of those need to show up right now unless we have a problem. So I'm going to make those all go away on our display screen. And I think, yep, that goes away if I make it all go like that. Now we need to figure out what those values might be, what a reasonable value is for them. And let's go ahead and hit play here real quick and go to small. That makes sure we can see the right thing. And we can put our mouse in here. And it looks like our top one, we want the Y to be around, maybe 115. Something like that. So where we are initializing inside of our game for the various data, we should start setting that stuff inside here. We're going to need to do some more setting of values here. So the top margin, what do we say, 115?
Mhm.
115. Let's make that 115. And we'll set the bottom margin maybe to about, minus 165. And we'll make sure that is the bottom margin. And then we will do the side margin. And the side margin is going to be, looks like, well, let's do it on this side, because x goes up to 240, and we want it to be around 220. So I'm actually going to call this 20, side margin. And to be consistent, I think what we'll do is actually we'll make sure that that margin is actually the number of pixels between the edge and the top. So y goes up to 180, and we were saying that the top margin is 115. So the margin is really 180 minus 115. And our bottom margin is minus 180 minus 165, so I can do that math in my head. That's 15. And why don't we be consistent and make no, we'll leave it at that. I could have made it 20 just like the side margin, but let's make it different. Okay, so we know what our margins are. Now we need to set that minimum padding. Did we add a minimum padding? Yes, we did. All right, so let's set the minimum padding, and let's make that maybe 10. Okay, minimum padding. Now we can't actually calculate where to put all this math in to make the size of the tile or anything until we know the actual number of tiles, the number of rows and columns that we're going to have in our game. So we're done now with initializing our data. Now we have to figure out the math for coming up with what those sizes should be. All right. So what happens when we click that we want to play a game? We need to initialize the data for the new game, right? And then we lay out the tile screen. So what we're going to need to do is we're going to have to add a new block that figures out these things. So let's make a block that says determine tile size and padding, something like that. Okay. Determine tile size and padding, and that's something we're going to have to do right away, really, because well, at this point we already know the rows and columns, and I've run out of space to put everything all at once inside my game. So I'm going to actually have to just scroll some of this off the screen for you. You're not going to be able to see it all anymore, but I will put this down here. Now let's figure out first what size our tiles need to be up and down. Okay, so I'm going to need a variable for that. I'm going to say tile size x and tile size y. And these are going to determine which size we'd like them to be, but they might come out to be rectangular. So we're going to, the actual tile size will come out after we figure that out. Now the tile size for y is going to be the amount of space we have times the size of the tiles we want times the amount of padding we want to have in between. Okay, so ideally what we want to have is just to know the amount of space that we have available between our margins, and that is, so tile size x, let's set it. It's going to be a little bit complicated here. Tile size x is, tile size y is our up and down. So the space that we have available to us is the size of y, which is from 180 to negative 180, it's 360, minus our two up and down margins. And those margins are top margin and bottom margin. Top margin, where's top margin? Oh, there it is, all the way at the bottom. Isn't that great? Top margin's at the bottom, bottom margin's at the top. It's great how that works. So what is this? 360 minus top margin plus bottom margin is the amount of space we have to work with. Okay? Now, from that, we actually have to also subtract. So we're going to get our subtractor. We're going to say that guy goes into there. So that's one number. But from that, we're going to have to subtract the number of rows we have minus 1 times the minimum spacing, minimum padding, right? Because if we have 3 rows, that means we have 2 spaces in between, right? So we're going to take the number of rows that we have minus 1. Oh, we're going to need to multiply that. The number of rows we have minus 1, which is this number of rows, minus 1, oops, popped out. Number of rows minus 1 times our minimum padding. Okay?
All right.
So that gives us the amount of space we have left for our tiles, right? And we're going to have to divide that by the number of rows.
All right.
So we take, because we want to find out what the tile size is in its y direction, we have to take up the space we have and divide it by the number of rows that we have. So we're going to pop that guy in there, take this entire thing, put it back in there, go back to our data, and put in the number of rows.
All right.
Okay? Now we're going to have to do something very, very similar for tile size X. So let's duplicate that. He comes in here. Tile size X is going to look like this, only we're going to go left to right. And to be consistent, I could say side margin times 2, but I'll just pop side margin in twice. So it looks somewhat the same. This should now be number of columns. Still by the number of minimum padding, and this should be number of columns. Okay?
All right.
There. No problem, right, so far?
Mm-hmm.
That is the tile sizes we'd like to have. Now the actual tile size which we're going to have needs to be the minimum of those two. Because we can't make it, we can't make it any bigger or it won't fit. And because we want them to be square, we're going to have to say that it's going to be the minimum. So what we're going to do here is we're going to say if, and then we can compare these two. So if tile size X is less than tile size Y, then, oh, you know what, we don't want if, we want if then else. If tile size X is less than tile size Y, then we're going to set the real tile size to tile size X. We want it to be the smaller one. If that didn't end up being the case, then we want to make it tile size Y. And that's what the size of our tiles is going to be when we're all done.
All right.
Okay? Now that we've figured that out, we can do more math. And that will be to figure out what the real padding is going to be between these things. Because now that we know the real tile size, we can figure out what the real padding is. And then we can start laying them out. And I can go put this guy back to where he was so he's not being overlapped. But that's we've used up our time for now. There's a little bit more math we're going to have to do for our next installment. Then we'll put the tiles onto the boards themselves. I hope that the explanation that we gave you early on helped you out to understand what we did last time and why we shuffled the board. It's going to become important when users can actually click on those tiles to show what's inside of them. We're going to use that list. And we're starting to do the math to figure out the tile size, and we'll finish that up and hopefully lay our board out in the next installment. So I hope you enjoyed this one. Thanks for listening. We're definitely making progress, and hopefully you're trying this along at home as well. We will see you next time. Bye-bye.
Bye.